now. Today, we are going to continue on with looking at some more different types of sorts. Uh, we just did the heap sort. We go back to the beginning and we talk about several different types of sort. Here we go. Okay. We talk about the generic types. We've had three generic types of sorts. And every sort falls into one of these three categories. And I don't know if you remember what they were. We really haven't had much with the third one yet, but we did the selection sort. We did the exchange sort. That was our bubble sorts and so forth. Selection where we picked the number and then moved it at the end. And we briefly have mentioned this insertion sort, and we're actually going to kind of look at that today. So a type of sort that's going to fit into the insertion sort. Today we're going to learn three sorts. First one, something called the quick sort. We got lots of sorting going on. Second one, merge sort. And the last one is called the Radix. Different ways to sort based on what your needs would be, based on what type of data, how little, how much. So one of these sorts that you learned over the period of, would you have four of them in 161, and now you have a couple in this course as well. Okay, quick sort. Quick sort. Now, one thing you have to remember about the quick sort is that it uses a pivot. I'm using pen instead of marker. Is it clear or should I switch to the marker?
It's clear.
It's clear. Is this better? Doesn't matter. Doesn't matter. Okay. I'm going to get a list of numbers. Here we go. 75, 70, 65, 84, 98, 78, 100, 93, 55, 61, 81, and 68. Your next assignment that's due Sunday is going to be to write one of these sorts. Well, actually, two of them, but I'm giving you the pseudocode for one of them because to code it would be kind of thought intensive, but not lines of code intensive. Okay, so we start out, we have a pivot. Here is our pivot. All right. What I'm going to do, the whole is all the numbers less than the pivot are going to be to the left of a certain spot. All of the numbers bigger than the pivot are going to be to the right of a certain spot. That same certain spot. So I'm going to come in and I'm going to start from the left and work my way right. Is 70 less than 75? Is this number less than my pivot? And the answer is yes. Is this number less than my pivot? The answer would be yes. Now I move to 84. Is this number less than my pivot? And the answer is no, so I stop. So I'm moving from this first spot over and then I stop. Now I'm going to start at the end and work my way to the left. Here we were looking for numbers less than, and if they were less than, they stayed. Now we're looking for numbers that are greater than, and if they're greater than, they stay. First number I look at is 68, and it's not greater than. So I stopped at 84. I stopped at 86. My condition now says swap. So this guy, woo, get back here, becomes 68 now. And this guy becomes 84. Back to where I left off. Is this less than 75? Nope. So I'm here and I stop. Is this greater than 75? Yes, I'm good. Is this less than, uh-oh, I need to swap again. I need to swap again. So now I'm going to come back. This becomes 61. This becomes 98. Is this less than? Yes, move on. Is this less than? No, I stop. I go to the end. Uh-oh, this is not greater than, so I'm going to swap. What happened with 78? I should have swapped that, shouldn't I? 78 and 55 should get swapped. This should be 55. This should be 78. And I can't make an 8. It looks like a 9. Okay. Then I came to the 100 and stopped. I went to 93 because this wasn't less than. I stopped. I go to the end where I left off. I move over. This is greater than. So I move over. This is greater than. So this is where I'm going to stop. Now I'm going to swap so that these numbers are to the left and these numbers are to the right. And what happens is this, my 75 is going to go where my smallest number was, 55. 55 is going to move over to the beginning. Now, what do I have between them? 70, 65, 84. Excuse me, 68 and 61, right? My pivot's in the middle. All the numbers less than are to the left. All of the numbers greater than are to the right. Guess what? After all that, one number is in the right spot. What's that mean? Well, that means I now take this list 55, 70, 65, 68, 61, and repeat the process. Meanwhile, I'm doing the same for this. Give me an R word that might be coming into play here.
Recursion?
Yeah, recursion. Recursion. So I need like a beginning in the array, an end in the array. This stores in the middle, and it's going to slowly recursively. I'm thinking, how in the heck would I code this? Well, I probably would do a couple more examples so I can figure out all the different cases I might need. I'll take a look over here at my new pivot is 55. I'm looking for numbers less than. I come to my first number and nope, that's going to have to get moved. And then all of a sudden I go to the end and I'm looking for numbers that are less than to swap it with. And I'm going, no. So the 55 is in a good spot. There's nothing to the left to send, but to the right, I would now use this list. Again, I would have the position here and the position here. Meanwhile, this is going on. It's kind of bizarre that a computer can do all this, if you ask me. I got the 100. Is it less than? Yes. So that would stay. Greater than? No, 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 no. Yeah. all of a sudden I'd have to swap out, bring the 68 to the front, 93, 55, 61, 81. I do have a array left on the left, nothing on the right, but I would keep calling and keep going. Woo. Pivot is 68. Uh-oh, greater than. Nope, it's not less than. Yes, it's less than. So this would become 61. This would become 93. I move left and right and I stop and I go, uh-oh, I'm done. 55 gets swapped out. 55 and 93. 68 is now stopped there. 93 and 81. I'd call the left, I'd call the right. Meanwhile, up here, there was no left call. I'd have a right call. What do you think? Questions? That's the idea behind the quick sort. I don't think I'd want to write that code, but this is the one you're going to get the pseudocode for. Conceptually, do you understand it? What would be a good test question? Just do one pass. Make sure you could get it right. All right. All right. Everybody's good. Okay. Second sort we're going to learn about today, the merge sort. Oh, there it is. And the merge sort is going to take two lists and merge them together. For example, 2, 5. I'm going to make these both sorted lists. 11, 16, 24, 25. And this is the concept of merging. Second list, 1. Need to make sure I don't reuse numbers. 9, 10, 20, 22, and 26. Okay. I'm going to start here, the beginning of this list. I'm going to start at the beginning of this list, and I'm going to merge them. How do I merge them? Which number is smaller? 1, done. Now I move over. I record the 1 in my new answer list. So we're going to have an array. We're going to have like an array. Then we're going to get an answer that's an array. I do the comparison. 2, boom, move over 1. I do the comparison. So I'm keeping track of these locations, 2 unique locations as I go through. Comparing 9 and 11. 9. Comparing 10 and 11. 10. Comparing 11 and 20. 11. Whoops. Comparing 16 and 20. 16. 20. 22. 24. 25. 26. Not too shabby. So I'm going to merge 2 smaller sorted lists to make a larger sorted list. Okay, so that's the idea of merging. Now, the merge sort, there's going to be 2 of them. First one is called the binary, and the second merge sort is called the natural. And you'll see why. When I think binary, I think base 2. So I'm going to get ready and we're going to talk about a binary merge sort. And the thing that I need to know, and the reason that it's called the binary is that the number of items is a power of two. Binary merge sort. All right, so I'm gonna go with, yeah, that was nice up here. I had 12 numbers. I'm gonna go with 16 numbers, and I'm gonna use this idea of merging so that I can sort a list of numbers. 75, 55. I used to do this in the classroom with 3x5 cards up on the board. It was a lot nicer. 15, 20, 85, 30, 35, 10, 60, 40, 50, 25, 45, 80, 70, and 65. And what I've learned is I need to go through the numbers so you can write them down while I'm saying them. Hey, all right. So first thing I'm going to do is take this bad boy, chinka 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 chinka, and I'm going to make two lists like I had up above. So my lists are going to be, I'm just going to write 75, 55, 15, 20, 85, 30, 35, 10, 60, 40, 50, 25, 45, 80, 70, and 65. Okay. So the idea is I'm going to have a list and I'm going to turn it into two lists. Now I'm going to do some merging to turn it back into one list again. Now this is power two. So I'm going to go 2 to the 0 power. I'm going to take the first one and the first one and pretend they're their own individual list. So I'm doing one at a time. That's 2 to the 0 power. 55 and 75. That's how I'm going to write them. 55, 75. Took a look at that first pair and sorted them by merging them. That seems a little silly because there's only one item in each, but you're going to see we're going to repeat this process. 15 and 20, 30, then 85, 10, 35, 40, 60, 25, 50, 45, 80, 65, and 70. Took a list, made new list by going one at a time. Power of two. This time I'm going to go two at a time. 55 and 75. I like that because they're already sorted. Second list, 15 and 20. Back to the first list, 30 and 85. Second list, 10 and 35. 40 and 60. 25 and 50. 45 and 80. 65 and 70. Up here, I went one at a time and merged them. I'm now going to go two at a time and merge them. 15, 20, 55, 75. 10, 30, 35, 85, 25, 40, 50, 60, 45, 65, 70, and 80. Getting closer. I went by ones, I went by twos. What do you think I'm going to do this time? Four at a
Threes.
time. Yeah, four at a time. Okay. In the first list, I'm going to do four numbers: 15, 20, 55, 75. Four numbers in my second array: 10, 30, 35, 85, 25, 40, 50, 60, 45, 65, 70, and 80. One list of two, one list of two, one list of two. Now I'm going to merge groups of four. Hmm. 10, 15, 20, 30, 35, 55, 75, 85, 25, 40, 45, 50, 60, 65, 70, and 80. Yep, eight at a time. Oh boy. My first eight, and then my second list is going to be my second eight. 10, 15, and I think you got the idea as we repeated this process, how this works. 25, 40, 45, 50, 60, 70, and 80. And merging those two lists, we would end up with sort. Kind of weird. See my beard, ain't it weird? Don't be scared. It's only a beard. Questions? Questions? Okay. Okay. As I said, there are two merge sorts. The first one was the binary. We had a list, we created two arrays and we merged them into one, then created two and merged them. We went by ones and twos and fours. Okay. Let me get a new piece of paper. The next one, the second one, is called the natural merge sort. Oh, there it is. And a list of numbers: 75. And this is when I don't have 16 numbers or 8 numbers or 32. I could use this one: 75, 55, 15, 20, 85, 30, 35, 10, 60, 40, 50, 25, 45, 80, 70, and 65. So this guy is called the natural merge sort. Now, last time we knew to go by ones, then by twos, then by fours, but this time we're going to do something a little different. We're going to go and list what's sorted, a sorted run, looking for runs. 75, crap, stop. There's 75. 55 is now going to go in my second list, but it's just a run of itself. Here we go. 15, 20, and 85. That's a sorted run. That's all going to go in my first list. Here's another sorted run. 30 and 35. That's going to go in my second list. Here's a run. I'm back to the first list. There's a run. I'm back to my second list. 25. There's a run. 25, 40, and 80. 25, 45, and 80. Then I go 70 and 65. So last time I went by the first time ones. Okay, but I can't do that this time. So how long would I go merging and merging until I moved on to something else? Well, you notice I start at 75. What do we got going on here? This number is smaller. So I'm going to merge the 75, this run, with a run down here. Well, this run is also only a single number. So I'm going to merge 55 and 75. How do I know how long to merge here? As long as the next number is larger, I stay in the merge. Same with here. So it looks like I'm going to merge this group until I found 10. That's smaller than the last number, so I would stop. And this group, ooh, what do we have here? All of this. I would keep going and then stop. Oh no, I'd run all the way out, wouldn't I? So my next one is going to be 15, 20, 30, 35, 40, 50, 70, and 85. Well, my next run here is 10 and 60, but I'm at the end. So it's just 10 and 60 merged with nobody. 25, 45, and 80 merged with nobody. And pour 65 out on the end. Okay, back to one list. Now I'm going to go two list again. Runs of sorted 55, 75. My next run 15, 20, 30, 35, 40, 50, 70, 85. Back to list one 10 and 60. List two 25, 45, and 80. Back to list one is 65. And again, I'm thinking, how in the heck would you program this? We wouldn't need pointers, but we would need some way to keep track of locations in these different arrays in order to do this sort. All right, moving on to the next line. Yeah, I think I got this run is going to get merged with this gigantic run to start. 15, 20, 30, 35, 40, 50, 55, 70, 75, and 85. I'm going to be making runs here and here. Oh, nice. Nice. 10, 25, 45, 60, 65, and 80. Again, how am I keeping track? Something's less than the next one, or I'm not at the end, or what, this is test data, working through understanding the problem before I can even start to program. Programming's more about thinking than typing. My first natural run, 15, 20, 30, 35, 40, 50, 50, 55, 70, 75, 85. My second run, 10, 25, 45, 60, 65, and 80. Nice. I'm down to my last two. I would run through this and have my sorted list. Hmm. Natural runs instead of calculated binary runs. To do run, 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 to do run, run. I met her on a Monday and my heart stood still. No. Any of you know that song? No. Questions on the natural merge sort. Okay. The last one was something that I called the Radix sort. And all of these are in the NIOP book, sports fans. They're all in the NIOP book. And, I like to sing. So I'm going to go bottom up, 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 bottom up. I'm on. Sorry, just me singing. I'm going to take a list of numbers 64, 8, 216, 512, 27, 729, 199, 550, 343, 125, 93, and how about another one yet? 676. Supposedly, back in the day, this is how our punch cards were sorted. But I don't know if that's true or not, but I'm going to go with that story. And I'm going to create 10 boxes here: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And these are like drop boxes of some sort where we're going to be dropping things in. All right. First thing I'm going to do is I'm going to run through my numbers and I'm going to look at the ones column. The ones column. And if the ones column matches one of these boxes, that's where I'm going to put it. Now, my first question is if I have the number 729, how would I get the 9? How do I get 9? This is code you should be able to do.
Would it be using the division that checks if there's a remainder?
You're going to have some sort of division going on here. Yeah. Take a minute and see if you can write down the lines of code. We'll call this num. And I want to get the 9. Num equals 2 or 729. I want you to write down the code to get the 9. If you want, you can type them up in the chat. All right, well, here's what I have. I have the number 729, and I'd like to get rid of 720 of that because then I'd be left with 9. How do I get 720? Well, if I take the num divided by 10, integer division, that should give me 72. So I'm going to say temp equals that, and then I'm going to take my number, 729 minus 72 times 10, and I think that'll get my answer. Okay. Again, I'm just scribbling code down that I'm going to need later. I'm going to temporarily get that 72, and then I'm going to take 720 and subtract it from my number to get my answer, which is 9. Okay, so I want the ones digit, and I'm going to fill up the columns according to the one digit. So 64 is going to drop down into the fours. 8, that's going to drop down into the 8. These are 3 digits. I don't know if it's 008. Can you just get away with working with 8 and so forth? 216, it's going to go in the 216 basket. 512, going to go in that basket. 27 is in 7. 729 is in 9. 199 is in 9. 550 goes over to 0. 343, 125. It looks like everybody gets to play. 93 goes on top, and 676 goes on top. Okay, so I did the ones column and I ran through and filled my baskets. Now I'm going to create a new list of numbers going from left to right, but doing bottom up, 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 bottom up. So I'm going to go 550. 512, 343, 93. How in the heck would we store this stuff? Chaining? Might chaining come into play with this? I don't know. 93, 64, 125. Bottom up, 216, 676, 27, 8. Bottom up, 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 bottom up. Okay, have a new list. I have a new list. Now, if I just did ones, what do you think the next round's going to do? Sort by the tens column. The tens column. Oh, I need to get the 5 here. I need to get the 1 here, the 4 here. And there's probably a block or two of code that would help me out to get that tens. All right. I'm going to put these in some baskets. Bottom up, up, up. I'm on fire. 550 is going to go into the fives. 512 is going to go into the ones. 343, 93, 64, 125. 216 is going to go in the ones. 676 is going to go into sevens. 27 goes into twos. 8 goes into 0. 729 is going to go into twos. 199 is going to go in the nines. Going to make a new list. Left to right, bottom up. My new list becomes 8, 512, 216, 125, 27, 729, 343, 550, 64, 676, 93, and 199. Almost ran out of room. Now I'm going by the hundreds. I'm going to go by the hundreds. 8, 5, 2, 1, 0, 7, 3, 5, 0, 6, 0, and 1. And of course, straight up integer division by 100 would take care of that for us. Final list, bottom up, 8, 27, 64, 93, 125, 199, 216, 343, 512, 550, 676, 729. Drop the mic. How about that for a parlor trick? Four sorts. Four sorts. Is there any you want to do one more time? You okay with all four of them? You don't feel like saying anything? You'll rewatch the video later when you forget how to do it. You have pretty good notes.